Okay, welcome to another presentation on integration by parts this time, and I want to start off by proving to you the Byparts formula. Now, it really comes from product rule just rearranged. Now, if we've got u and v are functions of x, yeah? Well then, the product rule states that to differentiate u times v, we need to do v du by dx plus u dv by dx. Hopefully that won't come as too much of a surprise. That is just the product rule for differentiation. Now, if we were to integrate everything here, we would come up with the following. We're going to integrate with respect to x. So I'm going to int with respect to x. Yeah, I'm integrating everything with respect to x. That would give me uv equals the integral of v du by dx plus the integral of u dv by dx. Now, all integration by parts is simply a rearrangement of this. Because if I was to now rearrange this and leave the u dv by dx on its own side, and just move this first term on the right hand side over, I would have uv minus the integral of v du by dx equals the integral of u dv by dx. And this is the Byparts formula. So all Byparts really is a rearrangement of the product rule. Now, it certainly doesn't seem as nice as that when you're actually performing it, because integration by parts can often be quite a long and tedious process, fraught with opportunities for sign errors as well. It's it's a tricky thing for the students to get their head around. Let's actually look at an example. So, in fact, a very typical Byparts problem is integrating x sine x, x cos x, or x e to the x. Those are the really typical ones. Now, if you've ever got x squared sine x, x squared cos x, x squared e to the x, that's also Byparts, but you're going to need to use it twice. X cubed sine x, x cubed cos x, x cubed e to the x, that's Byparts as well, but you'll have to do it 3 times. They're very, very common Byparts problems. So let's take a look at this one. You'll always assign one side of your product to something you quite like to differentiate. So u equals x, and therefore du by dx is 1. And the other side of your product, we're going to assign something which we need to integrate. So dv by dx is sine x, and therefore v is minus cos x. We're now in a position to apply the rule for Byparts. Now it's the same as uv, so minus x cos x, minus the integral of v times du by dx. Now that's going to be 1 times minus cos x, but let's put that minus outside and make it a plus, so I'm just integrating cos x with respect to x. And now I've got my answer, minus x cos x plus sine x plus c. And you're done. Okay, let's now look at another one which really, at first glance, looks wholly unsuitable for integration by parts. The integral of ln x. Now, the reason it looks unsuitable is because you have no product there. It's not ln times x, it's the function ln applied to the argument x. So, on face value, it doesn't look like Byparts is going to get us very far at all. I mean, how can we do it? We have no product. But if you look at this as 1 times ln x, then we're good to go. Okay, this time I'm going to write my u as ln x. I wouldn't put my dv by dx as ln x, because I'd be asking how can I integrate ln x, and by answering that question I'd say, well, first you need to integrate ln x, and it's like, well, that's the whole question I'm asking. So ln x obviously needs to be the thing we're differentiating, and ln x differentiates to 1 over x, natural log of x should I say. dv by dx can be 1. When I integrate that, I'm going to get x, because I'm integrating with respect to x. And so I end up with uv, which is x ln x, minus the integral of v times du by dx, which after you do x times 1 over x, just comes out as 1. And therefore we get x ln x minus x plus c. And by all means, differentiate that and see if you end up with just ln x on its own, and I'm sure you will, but that's a little check that you're doing it right. Now, you'll start to see as well, or you'll start to remember that integration is a bag of tricks. A very wise colleague of mine once said that to me, and I think they're absolutely right. There's lots and lots of tricks where you just learn the trick and that's how you integrate it. Ln x is a very good example of this. Anyway, I hope that's been useful for reminding you about the Byparts formula. Thank you for listening, and yeah, I hope it helps in the unit assignment. Bye bye.